Okay, so the next question is question number 7, which is basically you want to find R if 5 permutation R is equal to 2 times 6 permutation R minus 1. 6 permutation R minus 1. So if I divide both sides of this equation by 6 permutation R minus 1, I'll get 5 permutation R divided by 6 permutation R minus 1 is equal to, well, here the 2 would cancel out and then you will get just a 2. Now, now we need to simplify these two, and of course that is equal to basically 5 factorial over 5 minus R factorial, and then over here you have 6 factorial over, well, 6 minus R minus 1 factorial, which is equal to 6 minus R plus 1 factorial, which is equal to, well, 6 plus 1 is equal to 7 minus R factorial. So that is 7 minus R factorial. Now, and that's equal to 2. That is equal to 2. So now what you can do is that you can write this as basically 5 factorial over 5 minus R factorial times the reciprocal of this, which becomes 7 minus R factorial divided by 6 factorial, which is equal to 2. Which is equal to 2. So I can write this as 5 factorial over 6 factorial times 7 minus R factorial over 5 minus R factorial, that is equal to 2. Now, basically, this is the 6 factorial. You can write it as 5 factorial times 6, and I think that's where I made the mistake. Okay, and then you can simplify these two. And so now I can basically, to get rid of the 6 over here, I multiply both sides of this equation by 6. So I'll get 7 minus R factorial over 5 minus R factorial is equal to 6 times 2, which is equal to 12. Now you need to simplify these two, and it's a little bit tricky, okay? But it doesn't mean that you should get disappointed or anything like that, or it doesn't mean that, for example, that you should that you say that, for example, this is too hard, I cannot do it. Anything that you do in mathematics is basically logical steps that you take that take you to the final answer. And so it's always possible to take one logical step, and then after that you can take the next logical step, and so on and so forth until you get to the answer. That means that, and it's always possible to figure out what to do as your next step. So mathematics does not really need any sort of I mean, you don't need to be really smart, or you don't need to be a genius or anything like that to be able to do mathematics. As long as you understand simple logic, you can do mathematics. Anybody can do it. But of course, well, you need to have patience, and all the things that you don't understand, you need to basically go back and understand them. Meaning that, for example, of course, suppose that, for example, 0 factorial is equal to 1. And this is a definition. This is a definition. So there is almost no way to understand, for example, why this is so. They have defined it to be so, or to have this value. So these things you need to, the definitions, of course, you need to understand in mathematics, and also there are the basic things in mathematics that are always important. For example, taking the LCM of two numbers, taking the HCF, for example, of two or some numbers, taking basically, there is, for example, the prime, for example, factorization, and so on and so forth. These simple things are the basics of mathematics, and then from there you can get to calculus, you can get to anything in mathematics, provided that you understand the simple basics. Now, for example, in the case of these two, the way that you can simplify this is that if I write 7 minus r factorial, what that means is that it's 1 times 2 times 3 times all the way up to 7 minus r. If I write 5 minus r factorial, that's the same thing as 1 times 2 times 3 times all the way up to 5 minus r. And so now, since these are being divided, this one is being divided by this one, so you need to find some way to simplify these together, meaning that either basically you, for example, either you take this one, the upper one, and get to the term before this, which comes here, and the term basically, you get basically to the term before this, and there is another term before this, and so on and so forth, and all of these are being multiplied together. So either you get to this term and you will find this term, or you get to this term and you will find this term, and so on and so forth. Or you do the same thing with this here, meaning that you figure out what is the previous term to this one, and then see if you can get this one. Or you can figure out what is this term here, and maybe it's the same thing as this one, and then you can just simplify them together. And in such cases, you need to do a couple of experiments. So the experiment that you make here is that, for example, you need to know what happens if you move in this direction. Meaning that what is the term previous to this term here. So when you have basically expressions like, for example, n minus 4 factorial or things like that, that's easy because you are subtracting some, for example, some value from n, and it's easy to figure out such things when you have your variable over here. But right now my variable, you can see that my variable is being subtracted from some number, and this is a little bit more complicated than this one. I mean, not really more complicated, but working with it is a little bit more complicated. So what you want to do is that Of course, you know that, for example, r in this expression, the expression is 7 minus r. R in this expression is not supposed to be equal to 0 because, well, in the context of, for example, permutation, of course, R is not supposed to be equal. It could be 0. We could take it as 0 as well, but for now I'm just assuming that R is not equal to 0. And moreover, R is not supposed to be greater than this number, because if that happens, suppose that, for example, R is equal to 8, then 7 minus 8 is equal to -1, and you're supposed to have all natural numbers here and not negative integers. So R has to be, you could say R has to be less than or equal to 7, for example, in this case. So what that means is that, for example, let's take R as equal to 1, for example, just some arbitrary value for R. If R is equal to 1, then 7 minus 1 is equal to 6. Then that means that the last term over here becomes 6. And so that the term that comes before that, the value of that term, would be equal to 5 if I keep the same value for R. So now if I keep the same value for R, 7 minus R is supposed to be equal to 5 if R is equal to 1, and I want it to be equal to, I want this to be equal to 5, because when, well, of course, here 7 minus R becomes basically 6. Over here the value of 7 minus R becomes 6 if R is equal to 1. Over here the value of, over here if I keep the same value for R, of course the value of the expression has to become 5. So I've written a 5 over here, 7 minus R, and R has the same value. So but I need to subtract or add something to the expression so that I get to this term over here, right? So that thing which has to be subtracted or added to the expression, I take it as A and just add it to the expression. Now if it has to be subtracted, then you will get this value as a negative value. If it has to be added, then you'll get it as a positive value. So everything will work out for the best. So then what happens is that then you have A plus 7 and R is equal to 1, so minus 1 is equal to 5. That means that A, 7 minus 1 is equal to 6. So A is equal to basically 5, and this is 7 minus 1 is equal to 6, so minus 6, which is equal to -1. So your A is equal to -1. That means that you have to subtract a 1 from this expression to get to the term before that. So now 7 minus R minus 1 is the same thing as 6 minus R, right? So that means that the expression that we were looking for is 6 minus R. And it seems that we are going in the right direction, because as I'm moving towards 1, the value of this number here was reduced by 1 unit. So that means that if I again move one more time, I would get 5 minus R here. And that's exactly what I have here, right? So now these are all being multiplied and these are all being multiplied. So what that means is that I can write this as basically, you can see that all the way up to here I have 5 minus R factorial. So I can write 7 minus R factorial. I can write it as 5 minus R factorial times 6 minus R times 7 minus R. So that means that then 7 minus R factorial, I will write it as 5 minus R factorial times 6 minus r times 7 minus r over 5 minus r factorial, and that is equal to 12, right? So now I can simplify this whole thing, meaning that I can simplify these two together, and that means that then 6 minus r times 7 minus r is equal to 12, which means that 6 times 7 is equal to 42, minus 6r minus 7r plus r squared is equal to 12, which means that r squared minus 13r and 42 minus 12 is equal to 0, and 4 minus 1 is equal to, so that's where positive 30 is equal to 0. And then you can solve this equation to get the value of r. So now to get the value of r, 30 is the same thing as basically 2 times 15. And that seems to be what we need here, meaning if I write negative 15 and 2, the sum of these two becomes negative 13. Basically the product of them would be negative 30, which is not right. So I need to keep going. So that's 3 times 5, 6 and 5, 11, 10 and 3. So I can write it as 10 times 3. 30, I can write it as 10 times 3. So that means that negative 10 and negative 3 is, if you add them together, you'll get negative 13. Multiply them together, you'll get positive 30. So that's the two numbers that you need. So you write it as negative as r squared minus 10r minus 3r plus 30 is equal to 0. And then r times r minus 10 minus 3 times r minus 10 is equal to 0. And so then r minus 3 times r minus 10 is equal to 0, which means that r is equal to 3 or r is equal to 10. Now of course over here you can see that the expression that we have, so I got r as 3 and 10. R is equal to 3 or r is equal to 10. Now over here, if basically if r is equal to 10, then 5 permutation 10 doesn't make any sense, because suppose that, for example, you have 5 letters, and out of these 5 letters you want to create 10 letter words. You want to create 10 letter words. 10 letter words, which is not possible. So this answer is not acceptable. And so that means that r is equal to 3 is the right answer. I did solve this problem once before, but I forgot about this 6 that I had down here, and then went on with the solution and forgot this 2, and then at the end of the solution I got the wrong value for r, and so then I had to do it again. Anyway, that was number 7. There is a couple more examples here. These are all good examples. We can go through them one by one. Okay, so let's do this question as well. So it's 5 permutation R is equal to 6 permutation R minus 1. So if I divide basically 5 permutation R, if I divide it by this, which is 6 permutation R minus 1, I'm going to get a 1. And so 5 permutation R is equal to, this is the same thing as basically 5 factorial over 5 minus R factorial, and this is 6 factorial over 6 minus R minus 1 factorial, which is the same thing as 6 minus R plus 1 factorial, which is the same thing as 7 minus R factorial. So this is 7 minus R factorial. And that is equal to 1. And so I can write this as basically 5 factorial over 5 minus R factorial times the reciprocal of this, which is 7 minus R factorial over 6 factorial is equal to 1, which means that basically I can write this as 5 factorial over 6 factorial times 7 minus R factorial over 5 minus R factorial is equal to 1. Now this I can write as 5 factorial times 6, and then I can simplify these two. And so I can multiply by 6 both sides of this equation and get basically 7 minus R factorial over 5 minus R factorial is equal to 6. And so what that means is that now I think what we are going to get is, if I write this as basically 7 minus R factorial, and 5 minus R factorial is the same thing as 1 times 2 times 3 times all the way up to 5 minus R. Now if I can write over here 6 minus R, and I can write over here 7 minus R. And the terms are getting smaller and smaller. For example, over here, if I set R is equal to 1, some arbitrary value, 5 minus 1 is equal to 4, 6 minus 1 is equal to 5, 4. No, so I think this is wrong. 6 minus 1 is equal to 5. No, this is wrong. So I need to basically do this, the same thing with this thing over here. So this is 1 times 2 times 3 times all the way up to 7 minus R, right? And then if I write if I write 6 minus R here, if I write 5 minus R here, if I take some value R is equal to 1 here, then over here R is equal to 7 minus 1, which is equal to 6. 6 minus 1 is equal to 5. 5 minus 1 is equal to 4, so this is right. So that means that I can write this is 5. This is 5 minus R factorial. So I can write basically 7 minus R factorial. I can write it as 5 minus R factorial times 6 minus R times 7 minus R, and divide that by 5 minus r factorial, which is equal to 6. Then I can simplify these two, and what I can do is that now I can write 6 minus r times 7 minus r is equal to 6. Now there might be no, there is no way to do that. So 6 times 7 is equal to 42, and 6 negative 6r negative 7r. I think we have done this. R squared is equal to 6. So then we have r squared negative 13r, and 42 minus 6 is equal to 30. 42 minus 6 is equal to 42 minus, that's a 40, and then you have 4, so that's 36, plus 36 is equal to 0. So 36 plus 6 is equal to 42, of course. Okay. Now 36 is 2 times 18. It's 2 times 9. So 4 times 9 is equal to 36. Now if I write negative 4 and negative 9, that's negative 13, and the product of them would be positive 36. So I write r squared minus 4r minus 9r plus 36 is equal to 0. And so r times r minus 4 minus 9 times r minus 4 is equal to 0. That means that r minus 9 times r minus 4 is equal to 0, which means that r is equal to 9 or r is equal to 4. So we have r is equal to 9 and r is equal to 4. And of course r is equal to 9 doesn't make any sense, because 5 permutation 9 is not just simply not possible. So I have to reject this answer. And so r is equal to 4. Number 7 is 4. Now question number 8 is, how many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once? Using each letter exactly once. Okay, that means that you're not repeating the letters. So you want to know how many words with or without meaning can be formed using all the letters of the word equation, T-I-O-N, using each letter exactly once. When you say using each letter exactly once, that can be interpreted as not repeating any letters, right? So that means that you have 1, 2, 3, 4, 5, 6, 7, 8 letters here. You have 8 letters here, and when you have 8 letters, what that means is that, and you want to basically create 8 letter words, of course. So that's 8 permutation 8, which is equal to 8 factorial. So let's suppose that the answer is number 8 is, and 8 factorial, if you calculate it, you would get 8 factorial is 40,320. That's the answer. 40,320. That is the answer. Simple. The next question is, how many words with or without meaning can be formed from the letters of the word Monday, assuming that no letter is repeated if 4 letters are used at a time? All the letters are used at a time. All letters are used, but first letter is a vowel. Okay, that's also a good question. So you want to know, let me open my window. Okay, so you want to know how many words, you want to know how many words with or without meaning, can be formed or can be made from the letters of the word Monday, letters of the word Monday, assuming that no letter is repeated, assuming that no letter is repeated if 4 letters are used at a time, 4 letters are used at a time. Number 2, all letters are used at a time. And all letters are used, but first letter is a vowel. All letters are used, but the first letter is a vowel. Okay, so now to solve this quest, to solve this problem, you want to know how many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated if 4 letters are used at a time. If 4 letters are used at a time, that means that basically you're using, if number 1, if 4 letters are used at a time, that means that you have basically 4 letters here. That means that your n is equal to 4 and r is equal to 4. I'm assuming that I'm making 4 letter words out of the 4 letters using the 4 letters that are being used. Of course, that doesn't make much sense. The question is, I don't know, this would be, for example, 4 factorial, which is meaning that 4 permutation, 4 is 4 factorial, which is the same thing as 1 times 2 times 3 times 4, which is equal to 24, for example. I'm not sure if that's the right answer here. Or maybe it is basically you have 1, 2, 3, 4, 5, 6 letters here. Maybe what they mean by that is 6 permutation 4, something like that. But let's see. Number 9 is 9. Sorry, number 9 is 360. So 6 permutation 4 is the same thing as 6 factorial over 6 minus 4 factorial, which is equal to basically 6 factorial over 2 factorial, which is equal to 6, basically 2 factorial times 3 times 4 times 5 times 6 over 2 factorial. Then if you which is that's basically the same thing as 12 times 30, which is equal to 12 times 30, which is equal to 360. So what they mean by this is basically, what they mean by this is actually, when they say 4 letters are used at a time, what they mean by this is basically means taken at a time, meaning that you're taking all of the 6 letters, but then you're making basically 4 letter words out of the 6 letters, and that would be 360. Right? If all letters are used at a time, then that would be basically number 2, which would be basically n is equal to 6 and then r is equal to 6, which means that 6 permutation 6, which is 6 factorial, which is the same thing as 1 times 2 times 3 times 4 times 5 times 6, which is the same thing as 24. 4 times 30 is equal to 24 times 30 is equal to 12, 1, 720, which is the right answer here, right? And then if basically if all letters are used but the first letter is a vowel, so if all letters are used, basically then the number of permutations is 720, but then the first letter has to be a vowel, and a vowel basically in Monday, your vowels are O and A. That means that basically you're taking all the you're taking all the letters, and that means that you're making these 6 letter words. You're making these 6 letter words, but over here you're fixing either O or A. You're fixing O or A. That means that basically if you fix O over here, then you have so basically in total you have 6 letters, n is equal to 6, meaning that you have 6 letters in total. And since you have 6 letters in total and you have already used one of them over here, that means that for these 5 placeholders you have basically 5 letters left. So the permutations of these 5 letters would be 5 permutation 5, which is equal to 5 factorial. Now, since I can fix basically I have 5 factorial permutations if I fix O at the beginning. If I fix O at the beginning, and then I would have the same number of permutations, 5 factorial permutations, 5 factorial permutations if I fix A at the beginning. And so the total number of permutations would be equal to 5 factorial plus 5 factorial, which is equal to, which is the same thing as 2 times 5 factorial. You know that 5 factorial times 5 plus 5 factorial is 2 times 5 factorial. This is the same thing as A plus A, for example, which is equal to 2A, right? So that's 2 times 5 factorial, and 5 factorial is the same thing as 1 times 2 times 3 times 4 times 5, which is the same thing as 6 times 20, which is equal to 120. So that's 2 times 120, which is equal to 240. Which is equal to 240, which is the right answer, right? So that's number 9. Number 10. Number 10 we have 69. And how many of the distinct permutations of the letters in Mississippi do the 4 eyes not come together? That's a confusing question. In how many of the distinct permutations of the letters in the word now Mississippi is a tricky word. It's M-I-S-S-I, again double S, I, then you have double P and I. Okay, so that's the word here. Do the 4 eyes not come together? Now, in order to calculate this, basically the question is, in how many of the distinct permutations? Well, of course, the permutation by nature is distinct, although in such cases it's not going to be distinct, because your letters are the objects are repeated objects, so you have to take care of that. Otherwise, permutation itself is distinct. So it says that in how many of the distinct permutations of the letters in the word Mississippi do the 4 eyes, so you have 1, 2, 3, and 4 eyes here. Do the 4 eyes not come together? So there is no way for me to calculate this, that for example, to calculate the permutation the permutations of the cases where the eyes don't come together. Don't come together. So what you can say, there is no way to calculate this. It would be, I mean, there is no way to define this situation, or to define some sort of condition for that. So we need to do something else. What we need to do is that you could say that basically the distinct permutations of the letters of the word Mississippi, you could say that the distinct, I call this, for example, A, right? Now the permutations, the distinct permutations of the letters of the word, and by the word I mean Mississippi, I call this B, for example, all the possible distinct permutations of this word. And can I say that basically in these distinct permutations of the letters of the word, in all of these permutations, either the eyes basically come together, meaning that what I mean to say is that if I calculate the permutations of the cases where the eyes come together, right? That I can calculate. Call it C, for example. So that means that if I subtract basically the permutations of the cases where the eyes come together, and if I subtract this from basically the total number of permutations of the word, then that gives me basically the permutations of the cases where the eyes do not come together. So that means that B minus C, if I subtract this, basically the permutations of the cases where the eyes do come together, right? Do come together. So if I subtract this from the total number of permutations, the total number of permutations is B, and I'm subtracting from B all of these permutations where the eyes do come together. That gives me A, which is the permutations of the cases where the eyes do not come together. So now I can use this equation in order to calculate what I'm looking for. So that means that I need to calculate these two, and then using these two I can find this one. So the distinct permutations of the letters of the word, so that means that the distinct permutations of the letters of the word, and by the word I mean Mississippi, is what? So the word is basically MISSISS Mississippi, right? Mississippi. So that's the word that I have. In total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 letters. So I have 11 letters in total. M is fine. M is occurring only once. I occurs 1, 2, 3, and 4 times. I appears 4 times. And then S appears 4 times. And P appears 2 times. 4 times, and P appears 2 times, right? So that's the information that I need about this word. My brain is a little bit tired. Okay, so now basically to calculate the distinct permutations of the letters of the word Mississippi, I know that the word has 11 letters in total, and I have basically I occurs 4 times, S occurs 4 times, and P appears 4 times, right? So what that means is that if all of these letters were distinct, then of course I would calculate all the permutations of these letters as, for example, 11 permutation 11, which would be 11 factorial. Now, since these letters are repeated, I have to basically take out the times that basically the number of repetitions of these letters. So I have to basically, so I can say that, the distinct permutations of the word, of the letters of the word would be equal to basically 11 factorial divided by basically I is repeated 4 times. So you need to calculate the permutations related to this I. So you can imagine that, for example, you have for example 4 I's over here, basically 4 letters over here, 4 I's, and these will be repeated. So all the permutations related to these 4 letters would be basically 4 permutation 4, which is equal to 4 factorial. So over here I can write 4 factorial. By the same logic, all the permutations related to S would be again 4 factorial. All the permutations related to B would be 2 factorial. And so what that means is that this is equal to, well, 4 factorial times 5 times 6 times 7 times 8 times 9 times 10 times 11. And divide that by 4 factorial times 1 times 2 times 3 times 4 times 2. So then you can simplify 4 factorial with 4 factorial, and 2 times 3 is equal to 6, and 4 times 2 is equal to 8. So over here you have 5 times 7 is equal to 35 times basically 99 times 10 is equal to 990, and so 99 times 35, and you have a 0 there, so you have 5 times 1 is equal to 45, 4, 5 times 1 45, 49, 0, 3 times 1 is equal to 27, 2, 3 times 1 27, 29, and so you have 5, 16, 1, 13, 14, 1, and then you have a 3 over here, you have a 0 there, so you have basically 34,650. So now, just to make sure that I didn't make any mistakes, I will calculate this thing over here as well. That's 11 factorial divided by 4 factorial times 4 factorial times 2 factorial is equal to 34,650 is correct. So sometimes I don't make mistakes, so that's a good thing. I mean in arithmetic, of course, I mean. So that's basically the distinct permutations of the letters of the word, which is nothing but b over here. So this is the value of b that we talked about. Now the permutations, the other thing that we need to calculate now is basically the permutations of the cases where the eyes do come together. So when the eyes do come together, what happens is that you have the word Mississippi. You have the word Mississippi. Now over here we said that basically the letters, you have 11 letters in total, and you have 4 eyes basically. So when the eyes come together, you have one eye over here, another eye, another eye, and another eye. These, we will treat them as a group, as just one single object for time being. And then apart from that, I have all of these letters, which is basically 4 plus 7 plus another 7 letters. So 7 plus 4 is equal to 11, right? So now what I need to do is I need to calculate the permutations of the case where these eyes actually come together, meaning that I can treat them as a group, right? And so what that means is that now I have one object over here, 7 objects over here, so I have 8 objects in total, and I want to calculate the permutations of those 8 objects, which is basically the permutations of the 8 objects, or 8 letters, or basically objects, is basically 8 factorial, because you have 8 permutation 8, which is equal to 8 factorial over 8 minus 8, which is equal to 0 factorial is equal to 8 factorial. So this is equal to 8 factorial. Now there is a problem here. There is a problem here, and that is, and the problem is that basically these, and of course here the repetition of the letters have not been taken care of yet. So here the repetition of the letters have not been taken care of yet. Okay. Now the problem here is that, well, I has been treated as a group, so I'm not interested in the repetition of the letters I here. But you know that S and P were in these basically in these 7 letters. So you know that S has been repeated 4 times and P has been repeated 2 times. So I have to take this 8 factorial and divide it by basically 4 factorial and 2 factorial in order to take the repetition of these 2 letters out. So 4 factorial times 2 factorial. And moreover, there so moreover, that is basically that. So what we calculated here was the permutations of these 8 letters. So this 8 factorial that I got here was basically assuming that basically all of these i's are just one basically one single object. Now if and of course that's actually not the case, because these i's are actually 4, well, not different letters, they are, but you could say that these are 4 letters basically, not just one single object, for the sake of simplicity and because I wanted to be able to calculate anything really. So I had to treat them as one group. Now that I have gotten some number for those permutations, I can treat them again as just simple letters, meaning that the 8 factorial that I got over here, first of all, I had to take care of basically the repetition of these 2 letters, S and P, because S and P were a part of these 7 letters. So I divided this 8 factorial by 4 factorial and 2 factorial. That was basically one part. Moreover, since I have to basically take care of the permutations of these 4 letters as well, what that means is that for each permutation of these 7 letters, there is 4 factorial permutations related to these 4 letters, because you have 4 letters here, you have 4 letters here, and you have 4 placeholders, meaning that in order to calculate all the rearrangements of these 4 letters, you can write 4 permutation 4, which is equal to 4 factorial. So I need to multiply this 4 factorial by this expression, because there is for every permutation here, there is, or relative to every permutation here, there is 4 permutations. There is 4 factorial permutations related to these 4 letters. So you have to multiply that in. And moreover, the problem here is that all of these 4 letters are i's. That means that your i's have been repeated 4 times. Since these have been repeated 4 times, you have to take that out as well. So I have to divide by 4 factorial again. So of course, that means that 4 factorial by 4 factorial, you can just simply cancel them out, right? And now this basically, this fraction that we have here now is actually the number of or the total number of permutations when all i's basically come together taking all the repetitions into consideration. Okay, that is basically this thing over here. So now what I can do is that I can write this as basically 4 factorial times 5 times 6 times 7 times 8. And over here I have 4 factorial times 2. So 4 factorial and 4 factorial can cancel out. These two I can cancel out. And here I have 28 times 30. 28 times 30. And that is equal to 28 times 3 with a 0 there. It's 24, 2, 6, 8, 840. 840. So now this is this number that we were looking for. This is C. 840. So over here we said that A is equal to B minus C. Over here we said that A is equal to B minus C. B minus C. So your B is 34,650 minus 840, which is the same thing as 34,650 minus 840, 0, 1, 3, 16, 8, 3, 3. So that's the same thing as 33,810. And if that is the right answer, which I think it is, number 10, 33, 8, which is actually the right answer. Now what this is the total number of permutations, the total number of permutations of the word, of the letters of the word Mississippi, where when basically when all eyes do not come together. That means that this is all the cases, this is the permutations of all the cases when the eyes, me, C, P, right? So you have these 4 eyes over here. There are many cases, there are basically, there are 840 cases where these eyes come together like this. and so this is all the permutations of all the cases where these four i's don't come together. So basically, if you can solve, for example, this problem, that means that I suppose I would say that you have understood permutations pretty well. So there is one more problem here. Let's do this one as well. There is no harm in doing that. Although, okay, so let's do this example as well. It says, in how many ways can the letters of the word permutations be arranged if the words start with P and end with S? Vowels are all together. There are always four letters between P and S. Well, okay, let's do it. So in how many ways? You want to know? I think we need some more space here. Basically, in how many ways can the letters of the word permutations be arranged if the words start with P and end with S, if the words start with P and end with S, number two, if the vowels are all together, if the vowels are all together, and number three, if there are always four letters between P and S. There are always four letters between P and S. Okay. Now to solve this problem, what you need to do is, in how many ways can the letters of the word permutations be arranged if the words start with P and end with S? Okay, so the word permutations has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 letters. You have 12 letters here. So you have P basically appears once here, E appears once here, R appears once here, M appears once, U, T twice, A once, so T twice, A1s and I1s, O1s, N1s, S1s. So the only thing that is that appears more than once is T. So now what you can do, basically now what we want to do actually is basically find the number of permutations if the words start with P and end with S. So now I'm assuming that I want to make these 12 letter words. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. These are these 12 letter words. And these 12 letter words, they start with a P. So I fix a P over here. And they end with an S. You end with an S over here. So if you start with a P and end with an S, so what happens is that you have basically, so you can imagine that you have 12 letters here, and you have used basically 2 of your 12 letters in these 2 placeholders, right? And the rest of the letters you're supposed to use here. So that means that there are 10 letters to be used in these 10 basically placeholders. So you have 10 letters. You have 10 letters and 10 placeholders. You have 10 letters and 10 placeholders. To find the permutations of these of those 10 placeholders, you can just simply calculate 10 permutation 10, which is equal to basically 10 factorial over 10 minus 10 factorial, which is equal to basically 10 factorial over 0 factorial, which is equal to 10 factorial. So that is the case. That is the case if basically if you fix a P over here and you fix an S over here. But still there is a problem here, and the problem is that T occurs twice. So you have to take that out. You have to take that out, meaning that basically so this is the permutation of the 10 letters, basically not having taken care of basically T. Now let me show you another way to do the same thing. So here I got 10 factorial, right? So here I got 10 factorial. So another way that you can do the same thing, is that basically you have 12 letters in total, and basically you want to make these 12 letter words. Now 2 of the letters you have already fixed here. That means that 10 letters are remaining. 10 letters remaining. Now since 10 letters are remaining, this placeholder you can fill that with in 10 different ways. This placeholder you can fill that in 9 different ways, in 8, 7, 6, 5, 4, 3, 2, and 1 different ways. And you can see that this, and you can use the fundamental, you can use the fundamental principle of counting, which gives you basically then the total number, which means that then the total number of permutations, would be 1 times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10, which is equal to 10 factorial. What we got here. Now the only thing that here needs to be taken care of is the fact that t basically occurs twice. So you need to basically, and so you can say that the total number of permutations taking care of t, you will get that is equal to basically 10 factorial divided by 2 factorial, which is going to be equal to 2 factorial times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 divided by 2 factorial. And then you can cancel those out, and then you'll be left with 12 times 5 is equal to 60. That's 60 times, for example, 42, 72, 42, 72 times 10. 7 times 9 is equal, 8 times 9 is equal to 72. Is that right? 72 and 42. Okay. And then you have all of these numbers here. Basically 42 times 72 is equal to 72 times 42 is equal to 2 times 2 is equal to 4, 2 times 7 is equal to 14, 0, 8, 28, and you have a 4, you have 12, 1, and then you have 8 plus 2 is equal to 10, 1, you have 3024. That's 42 times 72. If I multiply that by 6 and multiply that by 6 and having 2 zeros there, I would get basically 6 times 4 is equal to 24, 2, 6 times 2 is equal to 12, 14, and 6 times 3 is equal to 18, 2 zeros there, that gives me 1814400. That is the answer for part 1 of the question. That is the total number of permutations if the words start with a P and end with an S. So number 11, that's 1814400. That is the correct answer, by the way. Now the next part of the question is, basically the question has 2 more parts to go. Okay, so the next part of this question is basically we have the word permutations, and we want to know in how many ways can the letters of the word of this word be rearranged or arranged if basically the vowels are all together. So if the vowels are supposed to be all together, what that means is that you have the word permutation. So permutations, T-I-O-N. So the vowels over here are E, U, A, I, and O. Right, so you have 1, 2, 3, 4, 5, and 6 vowels. So we said that in this word we had 12 letters, T basically occurring 2 times. We have 12 letters and T occurring 2 times. So if that's the case, then if basically if all of these vowels are supposed to appear together, basically put together, what we have is basically E-U-A-I-O. E-U-A-I-O. These are 5 letters, 1, 2, 3, 4, 5. So I treat all of these letters as one group, as just one object. And then since I have 5 objects over here, then I would have plus another 7 objects. Plus another 7 objects. So 7 plus 5 is equal to 12, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 objects in total, or 12 letters in total. So now the permutations of, and so now you can think of all of these objects as basically 8, well, you could say 8 distinct objects, except that basically T appears twice. T appears twice. We will take care of the T, but for now let's treat them as 8 distinct objects. So the permutations of of 8 distinct objects is equal to 8 factorial. Now since T appears twice, and since T appears twice, I take my 8 factorial and divide it by 2 factorial to take the permutations of T out. And basically taking the permutations, of the 5 vowels, into consideration, so what I will do is that now, that means that now I'm basically I am not basically treating these as one object. I'm treating them as 5 letters. So I'm taking the permutations of those 5 letters also into consideration, meaning that I write 8 factorial by 2 factorial, and I multiply it by the permutations of the 5 vowels. So that would be 5 factorial. And of course, as you can see, nothing is repeated here. So we have no problem there. We don't have to take anything out or subtract anything. So we are good to go. So that means that then you can write. That means that then you can write basically, well, 8 factorial times 2 factorial times 3 times 4 times 5, and divide that by 2 factorial, and then you could simplify these two. And then 8 factorial is the same thing as, I think, although it's not very necessary, but it wouldn't hurt to memorize a few of these all the way up to, for example, 10 factorial. So this is the same thing as 60 times 8 factorial. 60 times 8 factorial. Now 8 factorial is the same thing as 40,320 is 60 times 40,320. So then 4032 with the 0, another 0 here, times 6 is equal to 12, 1, 18, 19, and 24. And so that's equal to 24192, and 2 zeros there. So that's the number of permutations. That is the number of permutations if basically if all the vowels are, that is the number of permutations if all the vowels come together. If all the vowels come together. Okay. So that's part 2 of the question 2419,200, and that is the right answer. That is the correct answer. Now part 3 of this question is asking what happens, basically what is the total number of permutations of the word permutations if there are always 4 letters between P and S. Between P and S. Okay, so if there is always 4 letters between P and S, what that means, so basically we said that the word permutations has 12 letters T twice. You have 12 letters and T occurs twice. Okay, so now this part, third part of the question, is a little bit, it's actually, well, I did solve the problem. Where is it? Okay, so I did solve the problem, but it seems that my solution was wrong. And so now what we want to do, the third part of the question, basically the word that we have is permutations. You have 12 letters here and T occurs twice. And so we want to know that the total number of permutations of this word if there are always 4 letters between P and S. There are always 4 letters between P and S. So you need to basically pay attention to this. The solution is very simple. It's very simple to understand, but it's not probably the simplest thing to come up with. Now, the way that you can solve this part of the problem, and I did make a mistake here, a logical mistake I made here, is that, so now you know that the letters have to be arranged in such a way that there is always 4 letters between P and S. So that means that so what this means, basically that basically means that meaning basically the positions, meaning the positions of P and S, the positions of P and S are fixed. Now, when the positions of P and S are fixed, what that means is that basically we use permutation for the situations where you want to switch things and see what happens when you switch things. But when these 2 letters are fixed, then of course you don't have to switch them. Now over here you have 12 letters in total. You have 12 letters in total, and since two of them are fixed, that means that basically you need to basically rearrange only basically 10 letters. Okay, you need to rearrange only 10 letters. Now these 10 letters, so that basically means that the permutations related to the 10 letters one of which being T, which appears twice, is simply basically you have 10 letters, you want to calculate the permutations of 10 letters, which is equal to 10 factorial, and since T appears twice, you have to divide that by 2 factorial, right? So that's basically one part of the solution. The other part of the solution is that we said that basically P and S are supposed to be put in place in such a way that there is always 4 letters between them. Now since there are always 4 letters between P and S, so we have basically 2 times 7 different, which is equal to 14 different ways different ways of doing that. And I'm going to explain in just in a few seconds what I mean by that, of doing that. So what that means is that suppose that you have, and of course I came up with this explanation on my own. It has probably nothing to do with permutation or anything like that. See, you have the words, the word that we have has basically 12 letters, and we are constructing 12 letters using the 12 letters, right? So you have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So you have 1, 2, 3, and 4. 4 times 3 is equal to 12. 12 placeholders here. So I'm making these, I'm creating these 12 letter words, and basically the condition is that there is always 4 letters between P and S. Now suppose that you fix your P over here, there is 1, 2, 3, and 4 letters between them, and so your S comes over here, right? And so you can, now what you can do is that you can of course move these, but whatever you do, there has to be 4 letters between P and S. That means that your P can come over here, your S can come over here. Then basically then your P can move to this place, S can move to this place. Then your P can move to this place, your S can move, and so on and so forth. So what that means is that basically if basically your P is over here and your S is over here and you can move them, then basically this is one possible config. This is one possible way, and then you can move them over. So 1, 2, 3, 4, 5, and 6. 1, 2, 3, and 4. So 1, 2, 3, 4, 5, 6, and 7 different ways you can move this over, basically 6 times. So you can move it over 6 times, and then basically the position that they are in is already one possible position, and so you get another 6 possible positions. That means that in total that's 7 possible positions. 7 possible positions. And there is also the case, and there is also the possibility that you have all of these 12 placeholders here, but then your S is over here, and then you have 1, 2, 3, and 4, and then your P is over here, because there is no condition that says that, for example, from the beginning of the word has to start with a P or with an S. There is no condition there. So you can make the assumption that this can be the other way around, meaning that S is over here, so P is over here. So you you get another 7 possible positions, right? 7 possible positions. So you have 2 times 7 possible positions, which is 14 possible positions. And so by that logic, and using the fundamental principle of counting, then the total number of permutations of the word such that there is such that there are always 4 letters between P and S are basically 10 factorial divided by is equal to 10 factorial divided by 2 factorial, which is basically all of the permutations related to the 10 letters, and one of them was T, which appeared twice, so we divided by 2 factorial for that. So it's 10 factorial divided by 2 factorial, and you want to multiply it by 14. So that's basically 7 here, and then you get 10 factorial times 7, which is equal to I don't know what 10 factorial is 3,628,800 times 7. So if I multiply this number by 7, I will get 25,401,600. I'll get 25,401,600. 25,401,600, which is the correct answer, of course. But well, sometimes it's tricky. I mean, I had problem with the logic part of this problem. I couldn't figure it out on my own. But other than that, if you understand the concept, you can solve almost any problem that comes your way, related to, of course, permutation. So that's basically all of these exercises. So this was basically exercise 7.3. And in the next video, we will talk about combination. So I'll see you in the next video. Thank you.